In April 2024, a NASA aircraft crossed the northern Greenland ice sheet carrying a new radar instrument. The scientists were not hunting for a lost military base. They were trying to see through more than a mile of ice and map the bedrock below. Then a strange pattern appeared in the data. Parallel lines, hard angles, and structures where nature should have produced none. One scientist later summarized the moment simply: "We were looking for the bed of the ice, and out pops Camp Century." The lines belonged to a city that had disappeared almost 60 years earlier. It had streets cut from snow, laboratories, sleeping quarters, a hospital, and a portable nuclear reactor. It was built by the United States Army in one of the most hostile places on Earth. And behind the public story of Arctic research was a much larger military idea. Thousands of miles of tunnels and hundreds of nuclear missiles moving beneath Greenland's ice. The city was not destroyed by an enemy. It was defeated by the ground it stood inside. To understand Camp Century, start with a map of the Cold War. The shortest route between the United States and the Soviet Union ran over the Arctic. Greenland sat beneath that route like an enormous frozen observation platform. After the Second World War, American planners saw the island as strategically essential for radar, aviation, and early warning. Greenland was part of the Kingdom of Denmark, and a 1951 defense agreement allowed the United States to operate military facilities there. The most important was Thule Air Base, now called Pittafik Space Base, on Greenland's northwestern coast. But the Army wanted to know whether it could move farther inland. Could people live inside the ice sheet? Could heavy equipment operate there? Could a base be supplied through months of darkness and storms? And could compact nuclear power replace the endless convoys of diesel fuel? Camp Century was designed to answer those questions at full scale. The location was far from the coast, on ice thousands of feet thick. From the surface, the landscape offered almost nothing: wind, snow, and a horizon that erased any sense of distance. The Army's solution was not to build upward, it would build down. Construction began in 1959 with a machine that looked like it belonged in a different century. The Peter Snow Miller chewed long trenches into compacted snow. Workers placed curved steel arches over the excavations, installed prefabricated buildings beneath them, and covered everything again. The snow was both construction material and camouflage. The completed camp was a network of covered passages extending for roughly 2 miles. The main trench functioned like an underground street, with side corridors leading to workshops, communications rooms, laboratories, storage areas, and living quarters. Nothing about the process was simple. Every beam, generator, cable, meal, and spare part had to cross the ice. Tractor trains crawled inland from Thule carrying enormous loads. A breakdown was not an inconvenience. It could strand people and equipment in lethal weather. Inside, engineers fought a different problem: heat. A room full of people and machinery could slowly melt its own walls. Warm exhaust had to be moved away from the structures. Surfaces needed constant inspection. Ice and snow had to be treated as materials that were always changing. Camp Century was often presented to the public as a futuristic city. In reality, it was closer to a ship at sea, an isolated machine that demanded maintenance every hour it remained alive. At its busiest, the camp could support around 200 people, though its population changed with the season and mission. The Army tried to make underground life feel almost normal. There was hot food, medical care, recreation, mail, and movies. Private rooms and shared spaces sat inside prefabricated structures, separated from the ice by narrow air gaps. Fresh water came from a well melted into the ice itself. But nothing truly hid the environment. The camp creaked and shifted. Snow accumulated above it. Corridors changed shape. The outside world could become unreachable in bad weather. For researchers, however, the location offered an extraordinary laboratory. Scientists studied snow, weather, construction, and the behavior of the ice sheet. They also drilled one of the era's deepest ice cores, descending through the ice to sediment below. Decades later, those samples would help scientists reconstruct Greenland's environmental past. Camp Century's most enduring achievement may have come from research that military planners considered secondary. Diesel power at a remote base created a brutal logistics problem. Fuel consumed cargo capacity, and the generators demanded still more fuel simply to keep the camp warm. The Army's answer was the PM-2A, an experimental portable nuclear power plant. Its components were shipped north, hauled across the ice, lowered into a specially prepared trench, and assembled at the camp. In late 1960, it became the first Army reactor to supply electricity at a remote field installation. Calling it portable requires some perspective. This was not a reactor on wheels. Portable meant that its major sections could be transported and rebuilt far from conventional infrastructure. For several years, the reactor supplied electricity and useful heat, while engineers studied whether small nuclear plants could support isolated bases. It also created new complications: specialized crews, shielding, maintenance, and radioactive material in a place where every repair was difficult. The reactor was removed in 1964. Its successful installation proved that a compact nuclear plant could operate in the Arctic. It did not prove that the city around it could survive. Camp Century's public mission was Arctic engineering and science. Declassified records later revealed the larger strategic concept being evaluated in the background: Project Iceworm. Iceworm imagined a vast network of tunnels spread across northern Greenland. Special missiles would move between many possible launch positions, making it difficult for the Soviet Union to know where they were at any moment. The ice itself would conceal the system. Plans discussed hundreds of nuclear-armed missiles and thousands of miles of connected routes. It would have been infrastructure on the scale of a small state, buried beneath territory controlled by a NATO ally. Camp Century was never the completed missile base sometimes portrayed in sensational retellings. No operational field of nuclear missiles was installed there. Its real importance was as a test bed. The Army was learning whether the construction methods, transportation systems, power supply, and ice could support something far larger. The answer depended on a dangerous assumption: that Greenland's ice sheet behaved like solid ground. It does not. An ice sheet looks permanent on a human timescale, but it is a flowing mass. Snow compresses into ice, new layers accumulate, and the enormous weight slowly pushes the sheet outward. Camp Century's tunnels immediately began responding to that pressure. Ceilings sagged, walls moved inward, floors rose, crews trimmed and reshaped passages, but maintenance could not stop the deformation. The reactor trench became one of the clearest warnings. Its ceiling moved enough that engineers had to raise the structure below it. The deeper lesson was devastating for Project Iceworm. A missile network needed precise tracks, stable launch positions, reliable utilities, and tunnels that remained open for years. A base whose corridors required continuous correction was inconvenient. A nuclear deterrent built on the same principle would be unreliable. The ice had not failed. It was doing what ice sheets do. The planners had chosen a material that flowed and asked it to behave like concrete. Even so, the Army's 1965 engineering report remained strikingly optimistic. It argued that subsurface ice camps were feasible and that the knowledge gained would improve future designs. That conclusion was technically defensible on a small scale. With enough labor, some tunnels could be maintained. But the difference between maintaining a research station and stabilizing thousands of miles of military infrastructure was the difference between an experiment and a fantasy. Camp Century shifted towards seasonal use as the problems accumulated. The reactor was taken out. Personnel and equipment were removed. By 1967, the base had been abandoned. The cleanup reflected the assumptions of its time. The reactor and its major components left Greenland, but other material remained. Structures, fuel, wastewater, and different forms of biological and chemical waste. The expectation was that accumulating snow would entomb the site indefinitely. For decades, that seemed plausible. The camp sank deeper as new layers accumulated above it. Then climate projections raised a new question. If surface melting and thinning eventually overtook snowfall at the site, could meltwater reach the buried debris? The answer is still being refined. A 2016 study explored the possibility of exposure later in the century. A later assessment from the Geological Survey of Denmark and Greenland concluded that, under the scenarios it examined through 2100, meltwater was unlikely to reach the debris and the remains would stay buried. That does not make the waste disappear. It shows why the site remains a scientific and political responsibility rather than a solved historical footnote. Camp Century never physically reappeared. Radar made it visible. By 2024, its solid structures were at least 100 feet below the surface. Previous surveys had detected disturbances in the ice, but NASA's newer side-looking radar produced a view with more dimension. The old tunnels emerged as a geometric pattern inside the ice. The image was acquired almost by accident. It was not a treasure hunt, and it did not reveal a newly discovered city. The location and history of Camp Century were already known. What changed was the clarity with which technology could see it. That radar image creates a strange collision of timelines. A Cold War base built with steel arches and tractor trains appears through a sensor designed to improve predictions of future sea level rise. The same camp that tested whether ice could hide weapons now helps scientists understand how ice records motion, climate, and human decisions. Camp Century is easy to reduce to a dramatic phrase, a secret nuclear city under the ice. The truth is more interesting. It was an engineering success and a strategic failure at the same time. The Army proved that people could construct and operate a complex base inside an ice sheet. It transported a nuclear reactor to one of the most remote places on Earth and made it work. Scientists recovered an ice core whose value outlived the military program. But the experiment also exposed the limit that mattered most. A megaproject cannot negotiate with the physical behavior of its site. No amount of secrecy, funding, or strategic urgency could turn flowing ice into stable ground. Today the city still exists, distorted and buried. Its corridors are collapsing. Its structures move with the ice. Above it, the surface looks almost untouched. Camp Century was built to demonstrate control over the Arctic. Instead, it became a monument to the moment the Arctic refused.